Objective-C, by contrast, uses classes and objects, so maybe that's how an NS string is implemented underneath the hood. We just don't know. So what these several lines of code are doing ultimately is toggling back between these modes so as to use the C-based SQLite library while still using it in an Objective-C context. And then lastly, we close the database connection. And the rest of the code here, which we won't traipse through in any detail because it's pretty much the same as last week, the rest of the code just has to do with the UI table view and somehow defining the cells that you see when asked what goes at row 0, what goes at row 1, what goes at row 2, and so forth. But there's one thing I had to do behind the scenes. Recall that for quite some time under frameworks, we've had just UIKit.framework, Foundation.framework, Core Graphics.framework, which we finally started using tonight. Notice that in supporting files, there's something similar in Spirit, but it's a C library. So it's called a dynamic library. lib SQLite3.dynlib. This is a file that I did not drag and drop into my project per se. Rather, in order to use this library, and potentially any number of other libraries that Apple provides, I went into my target, went to build phases, went to link binary, and here is where you see the list of libraries that your application is using. By default, we've always gotten those 3 Objective-C libraries. Today, I needed a 4th library, namely the SQLite library. So to get there, I had to click that plus icon and then look through a list of libraries, and you'll see there's an overwhelming number of options, suggestive of just how much more you can do with the environment if you really dive in deeper. This happens to be a C-based library, and what do you think is inside of this library? What is the point of adding this row to this configuration table? I wrote SQLite earlier, right? I wrote the various function calls. Why do I need to add something like this? What must be inside there? What's that? All the function definitions, so the actual implementations. The only thing I had to do, even though we glossed over it earlier, is in my viewcontroller.m file, I did import this .h file. But in a .h file is not the implementation of some function. That typically is in some other file. So if I actually want the bits, the zeros and ones that collectively compose the SQLite statement query, the close query, the open query, I need to actually import those bits at link time, so to speak, and the means by which you do that in Xcode is via the project's own properties under build phases. So FYI. Yeah?
So most modern languages have at least one, if not 2, wrapper APIs for SQL. So, I mean, I don't mean to be lazy, but is there an Objective-C wrapper to do all this stuff?
Short answer, not as cleanly as would be ideal. Rather, there's an even higher layer of abstraction called core data, which is actually a pretty broad topic unto itself, but it's essentially an abstraction layer on top of SQL, or it can be on top of something else potentially, that allows you to define your entities and your relations without going into the depths of SQL. All of that would be generated for you. So short answer, no wrapper in Objective-C. Rather, Apple leapfrogged and went one level higher. Quite possibly, yeah. I've not used one, but there's not one that comes out of the box officially. Good question. So wonderfully useful, but also takes some getting used to. So keep that in mind. But much more powerful than something like a single plist file. So let me open up a little teaser here. Some of you may recall, or have at least heard of, a little game that for many years was amazing. And it looked like this. Let me go ahead and run this. I'm going to put the iPhone into a landscape mode this time. And notice that the computer is playing on the left. I, the human, am playing on the right by moving the cursor, or my finger really, up and down. And if I do this, and I can do this all day long, this will just play and play until I do something stupid, whereby if I forget to move, now he has a point. So why don't we go ahead and take our 5-minute break here. And I really lost fast there. Why don't we take our 5-minute break here, and when we come back, we will implement Pong together. All right, so first, let's resume by lowering expectations. This is an example called Paddle, which is among tonight's examples, whose sole purpose in life is to do this. But it's a good building block if we actually want to get to the point of actually having a bit of AI, if you will. You'll notice if you play the Pong game as it's been written, the computer will never, ever, ever lose, because as we'll see, the code is written in such a way that the paddle always moves to precisely where the ball is, no matter where you hit it. So only the human can lose that game. But we'll start by at least making our own paddle here. The cursor there on the screen is what my finger would be if we weren't doing this in the simulator. But first, we need a little bit of context. So let me switch over here for just a moment, just to paint a picture of how your mental model should be when it comes to graphics. So core graphics is the context. We've seen this library included for every example we've done thus far, but this is the first night where we're actually using it. And what's worth keeping in mind, is this system. Got to get better at this. This coordinate system here. So I looked for a newer image, but even Apple's documentation uses like the iPhone 3 for this example. But it's really just to paint a picture of the coordinate system in iOS, which is this plane where you have x coordinates on the right, y coordinates on the vertical. And this is just, the takeaway here is that the coordinate system begins in the top left-hand corner. So 10, 10 means 10 over and 10 down, not the opposite, as you might know from, say, typical Cartesian coordinates in algebra. So the catch is, as Apple's hardware has advanced over time, that resolutions have started to change, right? There was the Retina display in the iPhone 4 when the resolution essentially doubled. And unfortunately, this could have broken a whole lot of applications. But Apple actually anticipated something like this in the sense that you don't think of graphics in the two-dimensional world of iOS as pixels, but instead as points. And a point is still just a dot, but it might be 1 pixel, or maybe it's 4 pixels. It depends on your perspective. So they introduced this layer of abstraction called points so that irrespective of the actual resolution, the operating system will double your graphics as needed or shrink them as needed. Now this is a two-edged sword. It's on the one hand super convenient. On the other hand, if you've ever used an iPhone-only application on an iPad, it just looks kind of ridiculous when you zoom in at 2x. But that's really the only other alternative would be not to let the user play it at all. So now if we scroll over to this system here, you'll see the iPhone 4 and the iPhone 5. So the annoying thing here is that Apple didn't just double the resolution, they just kind of stretched it a little bit. So there were a few more pixels now on the screen. So this was more problematic. And there's still some apps out there that you might have on your own phones that now have letterboxing on the bottom or on the top with just black bars if you have an iPhone 5 and you're using somewhat older software that the developers haven't updated. So in this case, the number of points on the screen has actually changed. It's still 320 pixels across, but it's now 568 tall instead of 480 tall. So this is why Apple, as an aside, introduced something called auto layout with the most recent version of Xcode. And we saw me use it ever so briefly earlier when I said to vertically center the label that I dragged and dropped by choosing a vertical constraint. This is the new means by which you can essentially lay things out dynamically. Unfortunately, it doesn't quite work as easily if you're implementing something like Angry Birds or something graphical where there's a pixel precision when it comes to your graphics. So some people have to actually use different graphics for different modes. And that's why we've started to see more pings among the supporting files in all the projects. One is a bigger splash screen, one is a smaller splash screen, depending on the device that someone's using. So it started to get a little more Android-like in its nuisance here. So we'll see what happens next with the iPad, which is likely to become Retina before long as well, and a higher resolution. All right, so how do we go about implementing something as relatively straightforward as this? There's some new ingredients, but what are some now familiar ingredients if we want to implement something like this? What concepts or code can we steal from recent examples to implement this paddle, whose sole purpose in life is to go up and down? Yeah. Yeah, so maybe a pan gesture recognizer so that we can actually detect the user moving his or her finger up or down in this case, and just ignore their finger if it moves along the left-right axis. All right, so let's take a look at how this begins. App delegate, same as usual. App delegate.m, same as usual. So no magic there. So everything must be going on interesting. I have a new file altogether this time, a pair of files called paddleview.h and paddleview.m. Let's take a look at the h file first to see what this class is, and it looks actually pretty trivial. So I'm just importing UIKit, which is pretty typical, and then I'm declaring a class called paddleView, and it's of type UIView. So this is the first time we've actually declared in code our own UI views. We've had UI view controllers, main view controller, flip side view controller, but we've not declared our own UI views. To date, where have our UI views come from? Often the nib file by dragging and dropping. And in our no-nib example a couple of weeks ago, we did instantiate UI view objects ourselves in code manually. But even those were Apple's own UI views, the UI button and the UI text field. So this is the first time where we are defining our own view, because iOS doesn't come with a white rectangular paddle. So we have to create this somehow ourselves. So the means by which we've done this in the .m file is fairly simply by taking advantage of a method that is called automatically whenever a UI view object is instantiated. This is essentially an analog of like view did load, but that's at the UI view controller level. Now we're lower level at the UI view level. So draw rect for draw rectangle is what's called when it's time to initialize one of those little widgets that we've thus far been dragging and dropping. So here again, we're commingling some C code and some Objective-C. CGRect is the name of a core graphics rectangle, which is a C struct, a container with just data, no methods. I'm going to call this thing square. And on the right-hand side, we have a function called CGRectMake, which just returns a C structure, so a container with a few fields. And those fields are apparently 4 in number. The first two are going to be initialized as 0, third is 10.0, and the last is 60.0. Any guesses as to what those numbers are referring to? So close. Not color in this case, but dimensions. And one other detail. The XY, the initial placement of this thing. So 0, 0 is just implying that it's not going to be offset at all. It's just going to be in the top corner of whatever rectangle we're creating. The width of it's going to be 10 points, and the height of it is going to be 60 points. All right, but that's not enough. Now we've just created essentially a rectangular widget, something that could be, if Apple really liked our paddle, dragged and dropped in some future version of Xcode. Right? That's really all we've done here. But there's more complexity certainly for something like a UI button. But now let's see how we use this. In my viewcontroller.nib, notice I've done nothing except change the orientation. So if I actually click on that thing and go to the attributes inspector, one of those various checkboxes and drop-down menus would let me change from portrait to landscape mode. And that's the only change I made, in addition to then changing the background color from that default gray to black. So this is going to be my game board, so to speak. But if I now go to viewcontroller.h, nothing interesting in there. So the remaining magic must be in here. So notice inside of my view controller, I'm declaring a property that's of type paddleView, which is my own class that I created. And it's going to be called paddleView, lowercase p, capital V. Now, let's take one step back quickly. Where did paddleView.h and .m come from? Well, we haven't done this that often, though we did do it earlier with a strings file. Earlier, when creating this, I went to New, File, and then I just went up to Cocoa Touch and started with an Objective-C class, went to New. The class name I gave it was paddleView, and I didn't have it descend from NSObject. I had it descend from UIView. When I hit enter earlier, I got those two files for free. And that's when I dove in and then began to implement drawRect. All right, so now in this file, we have a few methods, init with nib name. And this looks pretty familiar, except for some new core graphics code. So init with nib name is, again, what's called as soon as the nib is loaded from disk. But that nib, by default, is just rotated landscape mode and painted black. Now I want to do one other thing to it. Self.paddleView means assign to my property what? The result of allocating a paddleView object and initializing it with a frame. So here there's a bit of a dichotomy. Now I am initializing this paddleView object to be inside of a canvas. So whereas before, if you're familiar with Photoshop, I created like an image. Now I'm creating the canvas on which to place that image. So the image can be offset in the canvas itself. The canvas can be bigger. And in this case, the canvas is going to have this image view, this paddle view placed on it 10 pixels to the right, 10 pixels down, and then the width of this overlay is going to be, as we'd expect, 10 points wide and 60 points tall. So what does that mean in real terms? This is why when we start this thing, let me quit the simulator. So if unfamiliar, you can double tap there, click and hold, quit paddle, or you can just click stop. And then you can hit run again to rerun this thing. Notice that it starts in the top left-hand corner, but the projector is kind of, the contrast isn't great. Take my word for it that that paddle is not truly in the top left-hand corner of the iPhone. It's instead 10 pixels down, 10 pixels over. So it itself is, with respect to itself, in its own top left-hand corner, but that's just because the image itself was only 10 by 60. Now we're painting it on a canvas by offsetting it 10 by 10. And why? I just thought it looked marginally prettier to offset it slightly from the edge of the phone. No other reason. All right.